Hello everyone, and thank you for using Danomics. In this video, I'm going to demonstrate how to use Python within the Danomics platform. Let's get started. To create a new flow, you can either go File, New Flow, or you can right-click on the folder you'd like to create it in and select New Flow. Now we'll give this a name. In this case, I'm going to call it Calculate vclay.flow. So for this flow, I'm going to do a simple calculation of the clay volume from gamma ray. Now, in reality, this is a calculation that you would normally do within your petrophysical interpretation, but for the purpose of learning how to use Python within a flow, this can be quite useful. To get started, we'll need to add some tools to our flow. So we'll start by adding a log input. And in the log input tool, we'll select the database. Next, we'll add a Python tool. Select that and hit add. You'll notice it has some starter code here. We'll come back to this tool here in a minute. And finally, we're going to be adding a log output. And we'll hit add. And we would put here the name of the log database that we'd like returned. Okay, so now let's focus on the Python tool. So when we look at the tool, there is a basic structure here. So first we have our imports here. So in this case, we're importing the base tool, which is some functionality provided by us here at Danomics. Then we have a class here, and within the class we have two methods. We have the update method and we have the execute method. You'll notice that in update here, we are not doing anything here, we're just passing. And in execute, this is where we will do the calculation. For the update method in general, this is where we would put any codes that are related to doing things like being responsive on parameter menus that we might use. And we can show an example of this in some of our other tools. And execute is typically where we will do most of the heavy lifting. So let's walk through some parts of this. So we start off, you'll see that within the execute method, we bring in the log object. This is what contains our log curves as well as some basic log information. We can see that it says here, if not log, so if the log object does not exist, return none. This allows us to exit the flow. Here in line 11, we have created a variable called gr, and we've set this equal to log.getCurve, quotations, gr. And what this is doing is it's using this getCurve method on our log object, and we're instructing it here to get the gr curve. So if there's a mnemonic gr for a log, we'll get that and we'll put it in the gr variable. If that mnemonic doesn't exist, this method will return none, and if it's none, we just want to write that log back to the database without doing a calculation. Subsequently, we then define two more variables, our gamma ray clean and clay parameters. Then we perform a calculation where we say vclay of gamma ray is equal to our gamma ray curve minus gamma ray clean divided by the gamma ray clay minus clean. When we use this log.getCurve method, it returns a NumPy array to us. The NumPy array that we get, that's what allows us to subtract off these integers and then divide by another integer here without creating any errors. Now, you may be wondering, how do we know that this returns a NumPy array? Well, if you have any questions about the methods, the references are available here. If you just go Help and select API Documentation, we have information about general flow structure, the log object, and as well as a number of tools that are available, where we specify exactly what is going on. So now that we've set up this very basic flow, let's hit run. Once we click run, it'll go through the basic process of initializing, running, and then finished. Okay, once the job starts running, you'll see that it only takes a few seconds to complete. And when it's finished running, you'll see that it has written out the database here that we specified in the log output here to our file folder. If we click on this database, we'll see that in a number of logs, we have properties called VCL underscore GR, which is what we used the flow and what we told it to name that curve in our Python tool. However, you'll notice that it's not available for every curve here. And the reason why is because we said get curves that are named GR. And here we have GRD and GRR, but not GR. So to address this, it would be useful to utilize our alias tables. We can do that in a couple of different ways. One way to do that is if we look at our API, and if we look at our alias lookup methods, we could use this to basically utilize the alias tables from our CPI config, or we can use another flow tool, which is called the CPI log calc tool. So let's add that in. So I'm going to add this tool, and I'm going to move it above our Python block. And here in the CPI log calc tool, this tool allows us to leverage the functionality from the CPI config. And in this case, we're going to get the curve GR final, which will already have the aliasing and unit conversions applied, the same as it would in a normal petrophysical interpretation. And if you wanted to use a gamma ray curve that you had already normalized, you could come in here and you could select your CPI, your tops, and your well headers, and that would then allow you to utilize the gamma ray actually out of your petrophysical interpretation, or any curves out of your petrophysical interpretation where you may have already normalized or performed bad hole repair. Once we've done this, we now come back to our Python block, and instead of using GR, we'll use GR final. Now we hit play, and once again it'll go through initializing, running, and then finished. Okay, now that this flow is finished running, let's look at the output. Now, when we inspect this database, we see that every well now has two additional curves. One is the gamma ray final, which we added in the CPI log calc block, and the second is the vclay from gamma ray that we added in the Python block. If we want to get a better understanding of what happened in the flow, or to see if there were any errors, we can come here and we can click on the job log, and it'll show us the code that was executed, as well as a summary of how long it took and how many logs and curves were processed at each step. Okay, there are a few more things that you may like to do in a Python-based flow to help yourself get a better understanding and to understand how troubleshooting may work within the platform. So let's take a quick look at those. So one common thing that you will do in a Python block is you'll often add some print statements to help yourself understand what is going on. And so let's add a couple of basic print statements here that may be useful to us. So let's say we wanted to print out the API for each log. So what we can do is we can say print, and then we can say log.get API, which is a method that we have on the log object, and this will print out the API. And let's say we wanted to print some type of basic statistics about our log as well. Well, to do this, we could, add another import. So we can import libraries. So in this case, we're going to import NumPy as MP. And let's say we wanted to use NumPy to calculate an average excluding all the NaN values. So we could say mean is equal to mp dot NaN mean, and we'll put in our gamma ray curve here. And then if we wanted to print that mean along with the API, say comma mean. Now we'll hit the run button, and once again it'll go through initializing, running, and then finished. Okay, now that has finished, let's take a look at what has been printed. So to see what's been printed, we come over here to our job log, we click the icon, and now we can see that it has printed the API and the mean for the gamma ray. So your print statements don't have to be limited to simple statistics like this. You can print anything you want, and this is often a useful way to help you understand how your Python flow tools are working. So there's one more concept I want to demonstrate here, which is how you can add a user interface to your Python tools. So here you'll notice that we have defined two variables. Now, in this case, this is quite a simple example, but you could imagine having user inputs here and not wanting your users to have to go into the code. In Danomics, you can add a user interface to your Python flow tools. An example of this is if we look at one of Danomics' pre-built tools, in this case, the null log data samples tool. So null repeated log samples, add, and you'll notice that this tool, it allows you to select some curves. It gives you options for using the alias table. You have a set of radio buttons here, and we have a couple of parameter input boxes. And if we look at the code, we can see where this is coming from. And to use this, we'll just need to make a few modifications. So I'm actually just going to copy this code and come back over to our Python block. And above our import statements, I'm going to add this code. In this case, we'll make a few modifications. So we'll call this calculate vclay. And we mainly only want to have a couple of parameters in here. So in this case, the two that we want to have are gamma ray clean and gamma ray clay. So why don't we name them as such? Let's say gr clean, and we'll call this gamma ray clean. And we'll put our default value for this at 20. And we can repeat this and say gamma ray clay. Give it the display name of gamma ray clay. And once again, we'll put this value at 100. So once we do this and we click outside of the tool, it then updates to show us a menu. And now we can see that we have gamma ray clean and gamma ray clay available to us. However, it should be noted that those right now are not wired into the flow. So this isn't actually going to do anything for us. So let's take a look at one of the pre-built Danomics tools again. So let's go back here, and we can see how these parameters were used here. So let's grab this example, and we'll come back to our tool here, and we'll come up above our update method, and we'll say value, and let's give this a name that's relevant for us. So it would be gamma ray clean, because that's what we've had here, and we're setting that to be a float, and it's a parameter. And then here we'll say gamma ray clay. You'll notice here that we're calling a couple of additional methods, in this case param and annotated. These are functions that we'll need to import. So if we come back over to this tool, we can see that we need to import the param, which once again we can just add that here. And we'll need to add the annotated library. So we'll copy this and we'll add annotated. And you'll see that you'll see that we've now got an error here, and it's telling us that we have an indentation error. So we need to fix that. And once we do that, and now that we've imported these libraries, you'll see that the error message goes away and that we're now ready to run this. So now we're getting GR clean and clay here, but we're not actually using them. So we can now remove these, and instead of GR clean, now because we're defining them up here in the class above the execute method, we need to reference them with self. So self.grclean, self.grclay, and self.grclean again. And now we are ready to run it. We can hit play, and once again, it'll go through initializing, running, and then finished. Okay, so now we see that that flow has ran successfully. Actually, this time we actually ran it with an extra tool, which was this null repeated log samples, although we didn't actually have the tool doing anything here. Okay, so the last thing that I want to show you in this video is now that we've built this front end and we have Gamma Ray Clean and Clay available, what would we do if we wanted to share this tool with our coworkers? Let's say this was a useful tool and not something that was just doing a very basic calculation like this, but was maybe doing something like executing a proprietary model that you want to run all your logs through. Well, to do this, you would come over here to the code section, and you'll notice there's a small icon here. This icon becomes visible once you put a front end on your code. And if you click on this, it says Save Python Tool, and then it also gives you the option to publish this to users in your organization. If you click on that and then click OK, this will now publish that tool called Calculate vClay to everyone within your company. And then when you do this, it'll then show up here in the list of flow tools under the category that you specify, in this case log processing. And also when you come here, then it would be available in the list for users to select. So this is a way for you to easily write a Python-based tool, put a graphical user interface on the front, and then distribute it to everyone within your organization. Okay, so this was just one example, and a very simple example of that, how you can use Python within your flows to perform a calculation. There are obviously a lot of use cases for this and a lot of different things that you can do. We don't expect you to know how to do all of this out of the box, especially with some of the specialized Danomic methods that we've built for you. So remember, if you need any help, you can always contact us at support@danomics.com. Thank you.